welcome to a brand new video. Man, that is like the worst catchphrase for the start of a video ever. But this is on the ratio test. This is example 3. In this video, I do not find the open interval of convergence, but in fact, I'm literally just going to show the ratio test to determine whether or not the following series converges or diverges. So let's get into it. So I'm going to have the series from n equals 1 to infinity of 2 to the n over n plus 2 factorial. Okay, let's get into it. So this is just equal to a sub n, well, the limit of the absolute value as n approaches infinity of the absolute value n plus 1 over a sub n. Alright, cool. That's cool. So now we take the limit as n approaches infinity of 2 to the n plus 1 over n plus 3 factorial multiplied by the reciprocal. And the reciprocal is in fact 2 to the n, and this is n plus 2 factorial. So let's just take the limit as n approaches infinity and rewrite this problem. So the limit as n approaches infinity of the absolute value of 2 to the n plus 1 over 2 to the n times the reciprocal fraction n plus 2 factorial over n plus 3 factorial. Factorial. Okay, so I'm going to explain how they cancel, dude, algebraically, because in my last video I'm just like, yeah, we've got an extra 2 on top, but why do we have an extra 2 on top? Well, I'm going to show basic algebra again. So this is technically the same as writing 2 to the n times 2 to the 1 over 2 to the n. That's why these guys cancel, because they are multiplicative. This is a multiplicative thing. Anyway, so that's why it's 2 to the 1. So now I'm going to kill 2 birds with 1 stone, and I'm going to show how to cancel out factorials with each other. So the way I see it is, if I know that n plus 3 factorial, it's higher than n plus 2 factorial, yeah? So that gives me a good sign that I have to do something to this guy. I have to manipulate him, you know? I've got to be like Sly Devil. So what do I do with him? Well, I say to myself, I'm going to leave him alone, but I'm going to multiply him by 1 less than him. So, n minus 2, n plus 2. So basically what I did was, I know at the end of the day that this guy has to cancel this guy somehow. So this is how you cancel factorials out. You say that you're multiplying the original guy by 1 less than the original guy, but you keep the factorial on the second fella. I know that doesn't really, it's not the best way to explain it, but basically n plus 3 times 1 less than n plus 3, but you leave the factorial and attach it to the second guy. So anyway, these guys cancel. I'm talking too much, so I have now 2, because I'm going to bring the 2 out the front of the limit because it doesn't depend on n. So 2 times the limit as n approaches infinity of 1 over n plus 3. And that's the absolute value. So what now? Well, I know that the limit as n approaches infinity of this is going to go to 0. This is going to 0. Which means that it's just 2 times 0, which is just equal to 0. And 0 is less than 1, which means that this series converges. And that... Wait, no. Whoops-a-daisies. The series does not converge. The series actually... the series does converge. I am so sorry. I'm just... I've got a lot on my mind. Yeah, no, the series does converge. The way I remember it is I know that for P series, that if it's less than equal to 1, the series will diverge, because that's the same as 1 over n. And we know that the summation of this one diverges, because it's the famous harmonic series. So the way I see it is the P series is opposite to ratio test. I know it's not a good way to remember it, but trust me, it's a good way to remember it if you don't like to think about it in the truly mathematical terms. So if you know that enough that the P series, if it's less than or equal to 1, it diverges, then the opposite must happen for ratio tests. But that isn't the best way to explain it to your teacher if the teacher asks you why. But it's a good way to remember it if you want to have like a layman's understanding of the concept. But that's how I understand it. So basically, yes, the series does converge, and that's the end of the video.